Welcome back, guys. We've got ourselves a mini lesson today, day 8. Now, usually these days are going to carry with them a quiz, which is why they usually are made so short. But for this first chapter, given kind of how this first week is, I'm going to give you guys a chance to focus on making sure you've got the content down. We already had our vocab quiz, so I'm throwing some things at you to make sure that we're on the right track, but I'm also not trying to overwhelm you. And so today, nice short lesson. As we get to the back half of this week, we're finally getting to see coordinate planes. And speaking of coordinate planes, our topic today is coordinate geometry. It's all about being able to solve problems when dealing with, well, the word I've already said way too many times, a coordinate plane. See if I can turn the brightness up a little bit. So the big thing today, the word that you're going to see a lot, is perimeter. Because when you're dealing with a coordinate plane, it makes it a lot easier to determine distance, length, and perimeter. And so we're going to be told to graph some figures today. And let's make sure we've got our graphing skills on here. We're good with that. Remember that the first part of a coordinate is x, the second part is y, and that applies for all three of these points. So negative 4, 2, that means we go negative 4 on the x-axis, and then up 2 on the y-axis. So there's point x, point y. You go 2 to the right, and then up 10, you've got point y. And then finally, z. We go 2 to the right and 2 up. And we're going to graph this figure. So we're told we actually have a figure here, so we can connect the dots. If they tell us we have a figure, that means these points are all connected. And would you look at that? We got ourselves what looks like a right triangle, a straight vertical line meeting a straight horizontal line with a hypotenuse. And so if they want you to find the perimeter, guys, what can we use to help find that? That's right. We've got the coordinate plane, the squares. So 1, 2, 3, 4, 5, 6, 7, 8. This is a length of 8 from x to z. 1, 2, 3, 4, 5, 6. Ooh, now here's the tricky part. We need to find this distance. But if this is a right triangle, we can throw it back to what we learned back on day 7. We know we can use the Pythagorean theorem to find this missing piece. So if we're trying to find the perimeter, we've got 8 plus 6 plus whatever this missing piece is. And so, to find it, we're busting out Pythag. Changing colors up here. So we know we've got 6 squared plus 8 squared equals our hypotenuse, which we don't know. I'm going to call that c squared, just for old time's sake, since it's our hypotenuse. So we add 36 plus 64, combine those together, and you're ready to take the square roots. And a lot of you guys are going to know square root of 100 gives us 10. So 10 units. But don't stop here, guys. They didn't ask us to find the hypotenuse. They asked us to find the perimeter. So we take this, we plug it in with the other pieces we know, and we end up finding out that the perimeter is 8 plus 6 plus 10. That would be 24 units. So we mixed in a little bit of everything there, graphing on the coordinate plane and Pythagorean theorem. All right. Here's what I'm going to do next. I want to let you guys see if you can plot the points and create the shape for number 2. So plot points to create shape. So you can pause the video and do that now. All right, so I know you guys. I know not only do probably a lot of us already set up this square, or actually, I guess a rectangle. But I'd say some of you guys have already counted the sides. We know from A to D, 0 to 6, B to C, 6, C to D, that's up 5, and A to B is up 5. And even more than that, some of you guys probably said, hey, I've got this. Perimeter. I know that is just when we add up all the sides of a shape. So 6 plus 5 plus 6 plus 5. You might see that written as 2 times 5, since we got 2 5s, plus 2 times 6, since we got 2 sides that are 6. And so your perimeter ends up equaling 22 units. But I got a scary question for you. I hope it doesn't scare you, but it might. What if I asked you to find the distance between point B and point D? So distance between point B and D. I'm going to pause the video for a second. I want you to think about, how could you do that? How could we find the distance here between these 2 points? Some of y'all might be calling me a moron right now. I literally said the word itself. We're going to use the distance formula. Anytime you want to find the distance between 2 points, you can always bust out the square root of x2 minus x1 squared plus y2 minus y1 squared. You can always bust out this formula, but it's going to require you to make sure you have the points right. So we know we've got B, which is at, I'll write it over here. We got B at 0, 4. We got that written, I'm sorry, 0, 5, my bad. We got that written up here. And D is at 6, 0. So 0, 5 can be our x1, which makes 5 our y1. 6, 0, that'll make 6 x2, and 0 y2. And guys, we're just going to plug it in here. Let me go back to red. So distance is going to be parentheses 6 minus 0 squared plus 0 minus 5 squared. And I'm going to let you guys see if you can find what the distance will be in units to the 10th place. That's to the 1 decimal place. Let's see what you got. All right. You simplify. We get 6 squared and negative 5 squared. And anytime you square a number, it's always going to become a positive. 36 and 25, we add those two together, we get 61. And when you take the square root of 61 and round that to the nearest 10th, you get 7.8, which checks out, because we know that's really a hypotenuse. It kind of splits this into 2 right triangles. We know really there's a right triangle at each of these corners. Look at these not straight right angles. But so yeah, it makes sense that this line would be the longest side if we were to create right triangles using it. Now to end today, guys, we've got 2 really good free responses. In this first one, I've got a feeling some of you guys who've ever helped around the house, maybe with renovations or things like that, maybe your family does them, you're thinking, okay, I've seen this before. If I'm just trying to find the perimeter of each room, I got nothing to worry about. I see I've got scales in feet, and I see, oh, wait, this is 20 feet. But how many squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. You know what that means. Each of these squares does not represent 1 foot. It represents 2 feet. All the way around. So we're going to have to reconsider some things here as we measure. One way we can do this is if they want us to find the perimeter of the kitchen, by counting around the outside of the kitchen. So part A. I'll do one of these with you, and then I've got a feeling that you guys are going to want to try and take a crack at the rest of these, because you may feel really confident about this, which I love. So we know the kitchen is right here. So that this is going to be the distance around the kitchen. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44. That's one way to do it. Another way to do it is to just straight up count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And say, okay, I've got 22 sides here, and each side is 2 feet. Either way, you get 44 feet there. So I'm going to give you guys a chance. See what you can do about the bedroom, the bathroom, and the closet. And be careful, because some of these may be a little bit trickier than you think. So take your time and let's see what you got. Okay, so the bedroom. We got 2 times 6. There are 2 sides that are both 6 units or 6 spaces long, plus 2 times the 4 spaces long here with the bedroom. That adds up to be 20. But the thing is, that doesn't take into account that each of these spaces are 2 feet. Times by 2, we've got 40 feet for the bedroom here. Next up, C. We've got the bathroom. So we've got 2 sides that are just 2 spaces long, so 2 times 2, plus you've got 2 sides that are, looks like 4.5 long up here and up here. Now when we combine those together, you get 4 plus 9, gives us 13. But again, we're not counting the fact that each of these is 2 feet. And if we're trying to tell the perimeter in feet, you got to multiply that by 2. So the bathroom, 26 feet. Let me kind of box these answers here so we don't get confused. Last one. The closet. A little bit bigger than the bathroom looks like. 2 times 3 plus 2 times 4. So we check that out. We find out that we get 6 plus 8, which is going to be 14. But then we got to multiply that by 2. So the closet is a little bit bigger than the bathroom. It is 28 feet. And there you have it. If you need to go back, take a look over these, you can pause the video, you can stand up, stretch. But guys, we just got one problem left. So let's finish strong. So to finish up today, we're not going to do a problem that has any numbers. We've been working with a lot of numbers today, but we're not going to deal with a problem that has any of those. We're not going to use the distance formula, Pythagorean theorem. We're not going to multiply or add. Instead, we're going to deal with concept, because I know a lot of people, even now, still get area and perimeter confused. And let's kind of clear up some of that confusion. Area is the amount inside a figure. It's the amount of space inside a figure. Sometimes we call this surface area. So it is the amount inside of a figure. Now perimeter, this is the distance, and here's the key word, around. So around for perimeter and inside for area. The distance around a figure. That is the key difference there, guys. So I'm going to leave you with this. Look over number 4, part A, B, C, and D. We're still thinking kind of remodeling a house, and we want to determine how much of each item we need to buy. But here's the thing. We need to make sure we know, are we thinking about buying this item in an area perspective or perimeter perspective? Because it's going to make a huge difference if you're thinking about one and it's really the other. So all I want you to do here is read over each scenario that you may need to buy and label it as either area or perimeter that we need to think about. Go ahead. Okay, I know some of you may have some beef with number 4, part A, but I want to remind you that wallpaper isn't just usually a line that goes around a wall. Wallpaper has depth. Remember, that goes back to the idea of surface area. If we have a wall that we're trying to wallpaper, guess what? That wallpaper is not just going to be one little thing around the wall. It's probably going to have multiple layers that completely cover the wall. And so what you've done is you've said, okay, this isn't a length, it's not a distance around something, it is how much of this wall is being covered by this wallpaper. That is an area problem. We're looking inside this shape. We're looking inside this wall. And it's like this for all 4 walls around the bedroom. So hopefully that maybe helps you a little bit on that one. I know the first time I saw that, that kind of confused me too. So guys, we've got Delta Math lines up. We have our multiple choice. We've got, if you haven't already done that for day 7 homework, we've got a few things kind of going on right now. So let's make sure we're staying on top of this. And if we're not, make sure you're asking questions. And I'll be talking to you guys real soon.